All right, so transformations of exponential functions, unit 13, day 2. So basically, we're going to take what we did last time and we're just going to move it around and transform it a little bit, but we're essentially doing the same thing, we're just transforming it, okay? So if we have that f of x equals a times b to the x minus h power plus k, h, so whatever's in the exponent, is your horizontal shift. And that's the x value. So this is in the exponent. And I need you to write this, so exponent. Just write that somewhere so you know that h is part of the exponent. Okay, and this is always opposite of what you think. So write that too. So h is in the exponent and it's opposite of what you think. Okay, that's going to go away, so make sure you have that written down. Now k is not in the exponent, so it's being added at the end, and that's the vertical shift. That's your y value. So h is in the exponent, and that's your horizontal shift, so that's left and right. K is on the outside, and that's your vertical shift, so that's up and down. Now, if a is negative, the function is reflected over the x-axis. Okay, so if there's a negative sign in the very front of your equation, then it's reflected over the x-axis. If a is greater than 1, if the absolute value of a is greater than 1, that's a vertical stretch. So if it's bigger than 1, you're stretching it out. And if it's less than 1, you're compressing it, so you're pushing it down and you're making it short and fat. And you're not just long and skinny is when you stretch it, that's when it's greater than 1. If it's not, you're going to shrink it down and you're making it short and fat. Okay? So let's identify the parent function and then describe the transformations. So if we're looking at a, the parent function there is just whatever to the x power. So that's going to be 3 to the x power. Now we have that plus 5 there. That plus 5 is on the outside, so it's vertical. That means it's going to go up or down. And since it's positive, it's going to go up 5. So this plus 5 makes that go up 5. Okay, now let's look at b. So here my parent function is 1/4 to the x power. You ignore everything else, just whatever's being raised to the x power. Now let's look at this. Now that 2, that's in front, so that's my a value. I should maybe write this. So 2 is my a value. 2 is greater than 1. So this is going to be vertically stretched by 2. Okay, and then we have this x minus 1 right there. So x minus 1, it's opposite of what you think. So h equals 1. That's going to move, or negative 1. Negative, you would think it moves to the left, is always opposite of what you think. So that's going to go right 1. Okay. So it's vertically stretched by 2, and it goes right 1. Now for c, the parent function there is 4/3 to the x power. Then let's just work left to right to do our transformations. So that negative sign reflects it across the x-axis. That plus 2 is up in the exponent, so it's opposite of what we think. Plus 2, you'd think it moves right, but it actually moves it left 2. And then plus 7 at the end will move it up 7. Okay? Now let's look at d. So my parent function here is 5 to the x power. Then my transformations, that 1/2, that's going to vertically compress because it's less than 1, so it's vertically compressed by 1/2. It moves right 1 because of the minus 4, or right 4 because of the minus 4, and then down 2 because of that minus 2. Okay, we'll go over transformations and stuff, or we'll just continue to go over these. I'll do them in class too, so if you have questions about this, you need to make sure you come to class ready to ask them, okay? Ooh, I just sneezed, okay. Okay, sorry. Now let's look at this one. So we have f of x equals 2 to the x plus 5 power. Well, first let's find the parent function. So our parent function here is 2 to the x. my transformation, that plus 5 moves it left 5. So I'm going to go to my graph, and I'm going to go left 5, and I'm going to draw a line right there. That is my new axis. That pink line that I drew right there is my new axis. That's where I'm going to graph everything off of. Okay? Now my parent function is 2 to the x power. So I'm going to make my little t-chart, -2, -1, 0, 1, and 2. And I need to find my y values, but I'm just going to do it for 2 to the x power. I'm not going to do it to 2 to the x plus 5. We already dealt with that plus 5 by moving this left 5. That's how we dealt with that. Okay? So let's plug that in. So f of -2 is 2 to the -2nd power, which is 0.25. Now f of -1 is 2 to the -1st power, which is 0.5. To the 0 power is 1. 2 to the 1st power is 2. And then 2 squared is 4. Okay, so I got all my values. Now when I graph this, we graph it off of that pink line right there. That is my new axis. So the pink line and then the normal x-axis, because that one didn't move. That's where I'm going to graph this. So -2 and 0.25 is going to be right there. Okay, it's not going to be at the normal -2. We moved the axis, so that's why it's right there. The -1 and 0.5 is right there. 0, 1, right there. 1, 2, 2, 4. Okay, then we can just draw that graph, and we're good. Now let's go domain, range, and behavior, y-intercept, and asymptote. So my domain, that's the x values. Remember, that's left to right. So the left is going to -infinity. The right's going to +infinity. Range is your y values. So from the bottom to the top, the smallest y value this will hit is 0. So it's 0 to infinity because it goes up forever. And behavior, as x goes to -infinity, that's the left side of the graph. F of x, so the left side of this graph is going to 0. And then as x goes to +infinity, f of x goes to, so the right side of this graph is going to +infinity. Now my y-intercept, it's not super clear where this crosses the y-axis. I can't really tell. So I'm going to plug 0 in for x and then just solve it. And we're going to use the original f of x. So this is going to be f of 0 equals 2 to the 0 plus 5 power, which is 2 to the 5th power, which is 32. So the y-intercept there is 0, 32. Okay, then my asymptote is the same as whatever value's on my range, so that's going to be y equals 0. Okay, let's do this one. So it moves up 1 because of that +1 right there. So I'm going to draw a line right there because we moved up 1 because of that +1. Now, when I plug this in, you only look at your vertical and your horizontal when drawing your new axis. Okay, so we used that +1, but I didn't use the 1/2 yet because that's not going to vertically move it or horizontally move it. That's just going to compress it. So f of x, I'm going to let that equal 1/2 times 3 to the x power. That's what I'm going to plug my values into. So that's going to be 1/2 times 3 to the -2nd power, which is 0.06. And then 1/2 times 3 to the -1st power is 0.17. 1/2 times 3 to the 0 power is 0.5. 1/2 times 3 to the 1st power is 1.5. And then 1/2 times 3 squared is 4.5. Now I'm going to graph those values from that new axis. So -2, 0.06 will be right there. -1, 0.17 will be right there. 0.5 will be right there. 1, 1.5, right there. And then 2, 4.5, right about there. Then you can graph that graph right there. Okay, so once you get those 5 points, just plot them and you can graph it. Okay, so my domain, that is your x values. That's from left to right, so negative infinity to positive infinity. Range from the bottom to the top. The lowest y value this hits is 1, so that's 1 to infinity. End behavior, as x goes to negative infinity, so the left side of this graph, f of x is going to 1. And as x goes to positive infinity, f of x is going to positive infinity, so the right side of the graph. My y-intercept here, if you don't know for sure, just go back to the original and plug in 0 for x. So that's 1/2 times 3 to the 0 power plus 1, which equals 1.5. So it's going to be 0, 1.5. Now my asymptote, same as whatever's on the range, so it's going to be y equals 1. Okay, remember to take the quiz. I will see you guys tomorrow.